Hi there, my name's Vince from mymatevince.com, and in this video today it's a trying to fix video off a little 3D printed pen. So this was sent in by a viewer named Lee. Now you might remember Lee because he is the one that sent in the faulty fluke meter, which is now working. So with this one, apparently it's got a blocked up nozzle. So that looks like a stand. That's going to be the actual plastic when it gets heated up to, you know, make whatever you're going to make. Looks like it's powered by USB. Ah, right, okay. Now, here we have it. And that goes in there. Right, so that's just all plastic. This is the bit, this is the clever bit here. Right, let's zoom in and see if we can make out what's going on. I believe it got blocked, and then the plastic coming through blocked up the, pushed off the nozzle. So I'm thinking all this mess here is the actual plastic. And he said that the wires come off the element. So it looks like we've got 4 contacts here. This is probably need to be pushed back to be level with that. So that one's still connected to that side there. But you can see this side here is broken. Also that wire there is broken. The third one is broken as well. It's gone under there. Okay, well, what we need to do is, I mean, it depends why it failed. Was it a case that it went a bit cold and then pushed through and forced this off? Because I presume the motor pushing it through here, I mean, we could have a little look in here. The motor, let's have a little look in here. The motor pushing it through might actually be quite strong. Or is it a case that the elements failed? In which case then it failed mid-use and then was cooling down and then got pushed off. So even if we sort all this out, it might be that the element itself has failed rather than that it's broken because it's been pushed off. Okay, so what we got here, we've got long tube going down to there, so that must marry up. So that bottom bit marries up with this bit here. So this is the speed control for the plastic coming out. And yeah, these two outer, so it's the outer 2 ones that actually do the heating. And maybe the middle 2 ones just do the measuring of the temperature, possibly. I reckon that's what it is. Outer 2's the power to make the element work, and the middle 2's temperature. Right, so we've got a motor here which is then going to convert itself into some kind of sideways, like a bevel gear type thing, to then pull on the plastic through that goes through this bit here. Oh, there we go. Oh, okay. Yeah. Yeah, so it's as simple as that. Can you see there's a little cog here that turns? There's just a little bearing here, and it just pulls it through. So obviously if you use something that was too thin, it wouldn't grip. If it was too thick, it wouldn't work either. So you must have to get the perfect size for it. Well, let's not worry about any of that. That all looks normal, doesn't it? Right, let's pop this back on, and let's concentrate purely on the front nozzle. Now, before I forget, this video today is sponsored by the My Mate Vince Massive, which is Saturnine Cinema and Robert Hughes. So they're the exclusive members this month. Big thumbs up to them. I'm thinking how to get rid of this here. I'm thinking, well, let's find out what, so this is PLA, isn't it? PLA, this stuff here. Well, it says ABS and PLA. Okay, well, let's find out the melting temperature. Okay, Google, what temperature does PLA plastic melt at?
130 to 180 degrees Celsius.
So I'm going to set my temperature to 150 degrees Celsius. That's not going to be enough to melt the solder. In fact, no, I'm going to do it to 130 because if possible, I don't want the rest of this to melt. So I'm just going to use my heat gun on here, 130 degrees Celsius, and let's see what happens. Hopefully it will get more pliable, and then I'll be able to get the tweezers and just pick them off. That's what I'm hoping. I've got the airflow set to 5 out of 8 and 130 degrees Celsius. Let's see now if it's going to start to loosen up. You know, I'm going to have to get some helping hands on here because it's just going to be rotating too much. But I think this is going to work. So you can see what I'm going to do now. I'm just going to keep trying to pick off bits. Now, look, this is going to take absolutely ages, isn't it? So I'm going to be just fast forwarding through the whole thing. Do you know what? Thinking about this, why am I struggling so much? I might as well unsolder the wires, because that's just going to help me. That's just going to help me no end, isn't it? All I've got to do is unsolder it from here and here, and then you see I can bend the wires back bit by bit, and then I can be a lot more brutal with the actual plastic. See, the problem is, you see, it's going to be melted all the way in here, but maybe if I can get it clear to here and get it soldered on, hopefully the heating off this, followed by the fact of new cable going through, new plastic going through, might force it all to come through the nozzle here. That's what I'm hoping. Now, isn't that going to be easier? And I can clean up the solder joints and stuff afterwards. Right, so this side actually looks okay. Now, in case you're wondering, you can actually buy nozzles. I mean, I don't know if it's a kind of universal fit or not, but they look to be about £6 on eBay. The problem with that is you can buy the whole pen for about £11. So I don't really think anybody in their right mind would be repairing it. There we go. So the two temperature wires are now free, which is great. So now I can be a lot more aggressive with this here. Do you know what? I'm going to get some proper pliers. Do you know what would be so satisfying? Getting the whole plug out with just one pull. Come on. Oh! Oh! Look at that! Oh! Oh, that is satisfying. That is satisfying. Woo! Right the way through. Oh, now that was nice. Excellent. Well happy with that. Now, let's push that back. Let's get the soldering iron on. Well, let's start with this side here. That looks to be in nice and straight. I don't know if they make the plastic on purpose smell like this, but it smells really nice. I presume it's not good for you. Now, have I pulled these temperature things up? Oh no! Oh! Oh, does that just pop in there though? Maybe that's still intact. Maybe that just needs to be popped back in. I was going to say they're sticking out too far. So this needs to be pushed down a lot more. Maybe that is that thing there is the little temperature probe. Probably is. But ideally I need that to go further into here. Let me try to straighten these legs up a little bit and push it down further. There we go. That'll do me. Hopefully that's still intact. Right, there we have it. So I suppose we need to check, see if we've got some sort of continuity reading between the actual element itself, don't we? Because maybe the element's broken. Really, I should have done that at the very beginning, and then it would save me having to do that work there. So I'm just going to go onto the ohm reading here. And I'm just going to go between here and here. Hopefully. Excellent. Brilliant. 2 ohms. So hopefully that's going to be okay. Just going to go on the temperature one, just see if it's giving us anything at all. Yeah. 39 kilo ohms. Well, I'm happy. It's doing something. Whether that's correct or not, I don't know. So now let's pop this back in to the 3D pen. So that doesn't matter which way it goes. Oh, we have little... Well, it does matter which way it goes because we've got a little notch out of it there. It goes that way. Little notch up at the top here. Well, that's not going to go anywhere, is it? Once it's all in its home. And then this is going to go into here. Line up the 4 holes. Like so. Press it down. And hopefully that will click into place. Okay, it wasn't a very satisfying click, but that is... Well, this side's in, but that side's a bit... That's not in very nicely. No, that's not in. Why is that side not in? I think I need to bend the plastic out a bit. Obviously it's made down to a price. So let's, oh there we go, it's just bent in there. So let's bend that out. And bend that out and then we'll get a nice firm click. Oh, that's annoying. Nearly had it. It's annoying that. Oh, I just pushed it that little bit too far. Right, okay, where's the notch gone? Notch is there. So now if I glue that with super glue, is it going to hold or not? Well, I had no option because old clumsy fingers here managed to break it. So I put it back together with the super glue and also a bit of epoxy. And now we're going to be picking up the video where we're about to test it. Okay, PLA. Excellent, look, it's climbing. And I believe when that red gets to green, that it means it's up to temperature. So it looks like the heating element at this moment in time is working, but whether or not it's going to be able to pull the plastic through, I don't know yet. But let's let that heat up for a bit. It's a real shame that I mucked up the nozzle there, because really then that would have been a perfect fix. And now you see, oh, that's getting nicely warm. Now it's not, is it? So I presume this is in Celsius, would it be? Lee sent me over some plastic as well. Whoa, it's gone to green, 190. Excellent. So I wonder, do you adjust the temperature here or not? 191. Yeah, so you do. Okay, well I'll leave it at 190. I presume that's correct. Right, let's put it in and start pressing this button here, and that's the speed here. Let's zoom out a bit. There he goes. So in here, and yeah, it's feeding it in. Look. Let's see if it's going to force the nozzle off. It might do. Maybe I'll have to support it a bit. Still going. Oh, it's starting to meet resistance. No, back. Oh, start deja vu. Right, look, it's just pushed it off again, but it was pushing it off beforehand. Okay, let's kill the power. Well, actually, I need to get this back out, don't I? Now, I wonder if the nozzle was good, would that have happened or not? I mean, the plastic thing that I broke. Oh, you just press it at once and it comes all the way out. Right, so I'm going to have to clean the nozzle again. So I'm not going to film it this time, it's going to be exactly the same as last time. I'm going to unsolder it and then clean it and then see this time if it is going to feed it through or not. So it's been quite a while later and I'm convinced the fault is with the element itself, and I don't think it's fixable because the power wires are definitely connected. As soon as one of those disconnects, it will still read here, it's just that this doesn't know that this is not working. So then what happens is it will just get cold, obviously. If one of the wires break for the temperature gauge there, then it will come up with error. Now right now I've got all 4 wires connected and this is red hot. I mean, I wouldn't even be able to touch that for a second, so that is red hot. Yet I don't believe that the inside of the element is hot enough to push the wire through. So what I'm doing here is I'm just manually doing it, because obviously I've got no control when the motor's pushing it in. It's just pushing it in with complete and utter force. Now I know this is broken here, and I appreciate it's going to be under a lot of pressure to, for example, get this thick wire, thick plastic, going through such a small nozzle. But I can fit in enamel wire easy through the nozzle here, and this enamel wire is 1/4 of a millimetre. And you can see that there's plenty of room there. Basically I've fed this all the way through to completely clean out the nozzle. So the nozzle itself is not blocked. Yeah? Okay, you can see that that's gone in there. Can you see that's gone all the way up into there? There's no way that that nozzle itself is blocked. I don't think the inside of the nozzle is getting the heat to it, even though the outside says it's getting up to temperature, because what's happening is it's just a wire that's coiled around it and then comes back on itself, so all the heat is being done from the outside. Now even if I was to up the temperature here, it's still not working. So let's see what the highest temperature is that I can push this to. Right, 210. Now that's the setting for ABS. At the beginning it asks you for PLA or ABS. So right now we're up to 210 as far as this is concerned. But watch this now. Any little bit of pressure at all and it just bends it out. And even if I put a huge amount of pressure on this down, so if I hold this in place here, and watch this, when I feed it through, right, already it's just bending it. There you go, broken. There, it's just broken the contacts again. And this keeps happening over and over again. It gets to here and then it just breaks. And it doesn't matter how long I leave this heat up for, this has been plugged in up to temperature now for ages. It's just not having it. So even when I put pressure on this down here, all that's happening is this is buckling on the inside just like it did to begin with. So unfortunately, I think the reason it failed in the first place is because for some reason this element is not working properly. Even though we're getting a full-on ohm reading going through it, basically it's near enough a short, it's like 2 ohms. For some reason it doesn't seem to be transferring the heat through to the inside, which is weird because it's ceramic. So it's like it's melting in the first bit, but it's not melting going all the way through. So yeah, I think it just needs a new nozzle. Now, am I going to buy a new nozzle for it? The nozzles are, I think, £6. I can get them cheaper from China. I can buy a whole pen for £10.99. So is it worth spending £5 less just to get a nozzle when you can have the whole pen and then use all the others as spares if things go wrong in the future? Not so sure. But I know for the point of the video it would be nice to see it working at the end, wouldn't it? So quite a while's passed and the spare nozzle has arrived. Now it's similar, it's almost identical, apart from annoyingly this end bit here. So I'm not sure whether, I mean hopefully it's all going to line up okay. Also the pins are a lot shorter, but I don't think it's going to make a difference because as long as it's making contact with the female parts in there, then it should be okay. So let's put it in and see what's happening. Now what I've done is I've just given this a bit of a clean up to get rid of some of the old super glue. Do you know what, looking at the amount of insulation material around here, I think that's the problem with the other one. The insulation had burnt off on the outside and I think most heat was radiating out rather than radiating in. Because think about it, it has to be very well insulated to keep that heat in, otherwise it's going to be going out. And I think that's what the problem was. Here we go. We're going to go. Right, let's plug it in. Let's see if it's going to heat up. Well, it's gone up to 20. It's very slow though. Very slow. 21. It's much, much, much slower than the other one, 23. Okay, well, we'll leave it for a few minutes because once it's up to temperature, it should stay at temperature, shouldn't it? No, it's come up with error. Right, let's... so it got to 100 degrees and then came up with error. Yeah, it's definitely red hot. So I do believe it is at 100 degrees. Well, I'm going to try to actually push this bit in here first and then see whether we can get that in over it. No, do you know what? They're not making a good enough contact in there. They're too short. So I suppose what I'm going to have to do is take off the front part here and kind of try to get it on this one here. So what I'm doing here is I'm taking the new working element, the ceramic white bit, and I'm soldering it onto the longer pins, the longer back section of the faulty element to see if the mixture of both of them will work. Right, okay, they're on. It's not the nicest soldering job in the world, but they're on. Let's see now if that's going to make a difference. Right, it's still taken a long time to heat up, which was not the same as the other one. But look, we'll see if it gets past 100 this time. Right, annoyingly, it's come up with error again, and it didn't even get to 100 degrees this time. So I think I'm coming to the conclusion that it's not worth buying a £6 part on an £11 item. Would have been just better to buy the £11 item to begin with. It's just that I thought maybe if I could replace the nozzle, it would make a better video. But it's non-standard. It's not the same. It's not the same part, is it? So I don't know why it's getting so far and then failing. It's a bit of a strange one. Unless, of course, it's thinking it's overheating or something. I'm not too sure. Error is what came up on this one when it wasn't reading the temperature. But this is reading the temperature, but then it fails after a short amount of time. It's strange. So I'm going to mess around it for a little bit longer. Obviously, if I can finish the video when it works, it'll be fantastic, but I don't think that's going to be the case. Quick while it's working. I've got to get my merch out in time for Christmas. MMV, there you go. Now you're probably wondering how I managed to get it to work. I think I know what's wrong with it. So let me just show you it working and then I'll turn it off, because once it's off I'm not going to go through the bother of getting it working again. There you go, I won't make you sit through that anymore. So how do I turn it off? Well, do you know what? I'll leave it on there, see if it keeps its temperature. So basically, this is the situation. I've been timing it. It errors every 2 minutes. So obviously, this is not the right nozzle for the pen. I think this nozzle is made for a pen that can give a lot more power into the nozzle to get it to heat up within 2 minutes. So it was heating up 1 degree every 15 seconds towards the end. And then after 2 minutes, it would error. I'd have to unplug it, plug it in back quickly and get it going again. And by then it would have dropped maybe about 5 or 6 degrees. And then I'd have to get it up to temperature. Well, not up to temperature. I lowered it right the way down to 160 because it was at 190 earlier. I couldn't get it up to 160 because it would time out after 2 minutes. There's obviously something in here that doesn't allow it to time to put power into the nozzle for more than 2 minutes. So what I did is I got my soldering iron, which is set at 480 degrees, and I was just tapping it against the ceramic while it was also heating. So then I could get it up to temperature within the 2 minutes. Now that it's up to temperature, it's keeping it okay, because I suppose the automatic cutout thing is only involved with the heating, not when it's up to temperature. So the pen itself does work. 100% the fault is with the nozzle. The replacement nozzle I've got, it's a generic one, but obviously it's not one that will work across all of them. The one that's needed for this is obviously wired up differently, that heats up a lot quicker or heats up with less energy going into it than the one that I've put in. So yeah, that is it. Am I going to be searching for more nozzles? No. You can see now it is keeping its temperature. And you can adjust the speed with this thing here, so you can see now it's coming out really quick and slow. So let's see if I can just end on a bit of a smiley face. So that is it for this video. Massive thanks to Lee for sending it out to me. Lee's a Patreon. Massive thanks to all the other Patreons. Massive thanks to the My Mate Vince Massive, and massive thanks to all the viewers that is still awake at the end of this video. So yeah, I enjoyed this video, even though it's not a fix. I feel that this is unfixable unless you were to get the exact right nozzle. And with this nozzle here, I've got a feeling that the insulation burnt off around it because there was a big black mark on it, and I think most of the heat was escaping on the outside rather than going into the middle here. So I feel like I know a lot more about them. I definitely wouldn't try to fix a cheap one again in the future because it's pointless, but maybe ones, the expensive ones, maybe ones that are like 100 or more, maybe they're well made and maybe they're designed to have replaceable parts in them. But my advice is, if you've got one that's like under £20, I don't think it's worth paying £6 for a nozzle for that one. Your money's probably better spent just buying another one for £20. And then I suppose it comes with a year guarantee, like everything else that you buy, well, in the UK at least anyway. So yeah, that is it for this video. Thanks so much for watching. Take care. Bye now.